Good morning students, this is Junita Mukherjee from SS Public School. Today we are going to start a new chapter related to the class 10th physics, that is magnetism, or you can say magnetic effect of electric current. Okay, so this is the chapter number 13. In this chapter we will learn something about the magnetic field lines, magnetic field due to the current carrying conductor, and how this particular field line is being generated and how we are going to get the effect of the magnetic field in this particular field lines in let us see. So here we have a scientist named Hans Christian Ørsted in 1777 to 1851. He has given this particular law of this particular he has given relation between the magnetic field and the current carrying conductor. And in this particular relation, what happens to the this particular relation is that whenever there is an electric field running, there is a magnetic field near its particular area. So where this can be tested with the help of the magnetic needle. When any electric appliance is working, or you can take a switchboard, and in the near the switchboard you place a particular current needle, magnetic needle. The magnetic needle will tend itself to the north-south direction. That is how the magnetic field is being exerted in this particular electric field, or the current carrying electric field. Okay, so this particular thing has been deduced in the 19th century, and which is called the electromagnetism. And in 1820 he accidentally discovered that the compass needle got deflected when an electric current passed through a metallic wire placed nearby. So his research later created technologies such as radio, television, fiber optics, and the unit of magnetic field strength is named by the Ørsted and in his honor. So this particular law is called the Ørsted law to honor his particular work. So magnetic field and field lines. Now the topic is magnetic field and field lines. You know a magnet. Okay, this is a particular magnet. Okay, so it is, let it be north and this particular thing is be south. So magnetic lines generated from north to south direction. If you place a needle here, okay, it will deflect in this particular direction, that is the north direction of this, and this is the south direction. Though it is a north side, it will deflect itself to the north-south direction. So here it will be here it will be south, and here it will be north. Okay, or you can say like this. This particular, don't write this thing. Just it will deflect like this. Okay, so we will draw a part just like this. Thus the fields are just in this particular order. These are the magnetic field lines in this order, generated in this order, and these are the field lines which are moving in the order from north to south direction. Okay, this is what we have, the magnetic field lines generated by the compass needle and bar magnet. So this is how the magnetic field is being developed around the magnet with the help of the magnetic field, needle. Now magnetic field due to a current carrying conductor. Suppose we have here a battery. Okay, so we have here a battery, small battery connected to it, and this particular battery is connected with that of the bulb. Okay, and this particular bulb is connected with that of a circuit or switch. Okay, so this is an open circuit. If you close the circuit, the current will move on in this particular circuit, and thus it will move. Okay. So how it is moving? When we switch on the circuit, the electricity will move, and if we brought a magnet near it, it will tend it to the direction north and south. This will be the north direction, this will be the south direction, and this is what the magnetic field with the current carrying conductor is being established. And if we change the direction of the current, that means if we change this direction, if we change, okay, suppose this is plus, this is minus, what happened? The direction of the needle will also change. This will point towards north, south, and this will point towards south direction. This is how the magnetic effect of the current carrying conductor is being done in this particular book which has been given to you. So there is an activity, please go through this particular activity in 13.3 exercise, please learn this activity 13.2 and 13.23, and please learn also this one 13.4. You will be able to get this particular activity done in your home if you have a magnetic needle, compass needle, and the electric appliances or the circuit connected with that. So this particular thing can be explained very well by you if being read properly. So please go through this particular topic, and we will be going towards or heading towards next topic is that magnetic field due to the current carrying through a straight conductor. So we have here connected a concentric circle, indicating the field lines of the magnetic field. We have taken here a thick wire through the center of this particular thick wire we have taken here. This is a field, and there is a thick wire we have taken it from this particular pole, and this is connected with that of the battery, and this is connected with that of the magnetic needle. So the magnetic field lines are being generated here also. That particular topic which I want to tell you will be, this is the important topic, and this particular compass needle is moved away from the copper wire, but the current flows through the wire remains the same. What happens to this particular wire, or you can say a variable resistance, what happens to it? The current, there will be a current this from this particular copper wire moving through this. So if this wire is going down, and there is a electric field in this particular wire itself, it will be there will be again a deflection in the magnetic needle if we take a magnetic needle near this particular wire. So in this what happens to the deflection of the current, let's see what is happening in this activity number 13.5. Take a battery, a variable resistance of rheostat or ammeter, plug key, connecting wires, and long resistance thick wire at the center normal to the place of the rectangular box. Take care of the cardboard is fixed and does not slip or down. So we have taken a cardboard, and this cardboard is connected copper wire vertically between the X and the Y points, and thus the sprinkle some iron fillings. This particular wire has been connected, and the iron fillings have been sprinkled out. The iron fillings will rotate in the concentric circles, because they will form a magnetic field here, and this particular wire is being connected, this copper wire is connected, and thus the magnetic field is there in the concentric circle, that is the right hand thumb rule, you can say. This is the conducting wire, and these are the concentric circles which are the magnetic field generated by this wire. So here we have connected the copper wire vertically between the point X and Y as shown in the figure. Sprinkle some iron fillings normally at the cupboard, and you may salt sprinkle from the purpose. Keep the variable of the resistance fixed position and the current through the ammeter. Close the key so that the current flows through the wire, and ensure that the copper wire placed between X and Y remains vertical. Gently the gap and cardboard a few minutes. Observe the pattern of the iron fillings. You will find that the iron fillings align themselves along the pattern of the concentric circles around the circle. And why do these concentric circles represent? These represent the magnetic field line. How can the direction of the magnetic field be produced? Place a compass at a point and observe the direction of the needle. The direction of the North Pole to the of the compass needle would give the direction of the field line produced by the electric current through the straight wire at the point P. Thus, the direction by the arrow. Thus, the direction of the magnetic field lines get reversed. The direction of the current through the current wire is reversed. So, if we change the direction of this particular current, okay. So, if we change this direction x to y and y to x, the field lines will concentrically break down, or it will move in the opposite direction. So this is activity number 13.5, which is also been given to you. Thumb rule I have already explained to you. If it is this current, these will be the field lines, and if it is the current, then this will be the field line itself. Okay, so this is the thumb rule itself, which is defined by this particular value. This is the current, this is the current field line itself, magnetic field lines. So I hope this particular topic has been very much clear to you. So moving towards or heading towards the next topic in the next session. Till then, take care and please read the topic. Thank you.